This is our last page of notes for today, and then you have a web assign to work on, okay? So for problem number one, this one I don't have to do anything too fancy because we do have the same base. I see that they both have a base of e. So like we said, right, if I had, this is a different problem. Let's say I just had, 3 to the x power equals 3 to the 2x plus 5. Well, if this is my setup, because I have the same base, we know the exponents are equal. So now I can say that x equals 2x plus 5, and then I can solve for x. Okay. So as long as you have the same base, you're in a great position to just solve by setting the numerators equal to each other. So because these are both base of e, I can set the the exponents equal to each other. So I can say that negative x squared equals negative 3x minus 4. I'm going to solve this by setting it equal to 0. So I'm going to go ahead and I'm going to add x squared on both sides. So now we end up with 0 equals x squared minus 3x minus 4. And now I have to factor this, right? I can solve for x by factoring. So I'm looking for two numbers that multiply to be negative 4, and those same two numbers have to add up to be negative 3. And I believe those are going to be negative 4 and 1. All right, so with negative 4 and 1, we can factor x minus 4, x plus 1. And that's going to allow me to solve and find out that x is either 4 or x is negative 1. So it's always a good idea to check your answer by plugging them back in. So if I test out this 4 first, negative 4 squared would give me negative 16. And then negative 12 minus 4 would also give me negative 16. So they're the same, so that does work out for me. And then I could test out the negative 1 here. If I plug in a negative 1 here, that would give me a negative 1. If I plug in a negative 1 here, that's 3 minus 4 is also negative 1. So these both will work out as possible solutions. All right, so factoring, again, never going to leave you. You're always going to have to learn how to know how to factor, so make sure your factoring skills are always top-notch there. For problem number 2, so again, thinking about what we talked about on the last page, I have this set up as an exponential equation. The way that I want to eventually solve this is to use logarithms, all right, or natural logs, depending on what our base is. So for a problem like this, I first just want to get the letter x all by itself as much as possible. And so what you might be saying is, well, if I've got 3 times 2 to the x power, I can undo that multiplication of 3 using division. So that's exactly right. I would have to divide both sides by 3, and the 3's will cancel, leaving me with 2 to the x power equals 14 when I reduce that. So this is a great first step because now I've isolated x as the exponent. And I still have to figure out how to get rid of that base of 2 though, right? So, and this is where we think about problems like number 4, right? So in problem number 4, we said, well, if I take the natural log, that's going to allow me to make the natural log of e equal to 1, and it will basically go away just giving me the letter x, because 1 times x is x. So when you choose what to do on both sides, I mean, yeah, I could do log base 3 of 2 to the x power equals log base 3 of 14, right? I can take the same logarithm on both sides, but that's not going to help me, right? Why would I take the log base 3? Because 3 to what power is 14? I don't know. 3 to what power is 2? I don't know that either. So choose a base that's going to be helpful to you. Don't just pick a random one. Pick a base that's going to be helpful to you, all right? And in this case, 2 is going to be that base that you have to pick, all right? In general, whatever your base is here, that's going to tell you which logarithm to use. So like if I had, let's say for example, I had e to the x equals 14, I would take the natural log of both sides. All right, because the ln of e is going to just be 1. If I had, let's say, 7 to the x power equals 14, well then I would take the log base 7 of 7x equals log base 7 of 14, okay? Because I know that log base 7 of 7 is just 1. So you have to be thinking about, whatever your base is here, that's going to dictate which kind of logarithm you use on both sides. All right, so for this one, like we said, the base is 2. So I'm going to do log base 2 of 2 to the x power equals log base 2 of 14. Now again, this is not 7. That's not a 7 over there. We don't know what this value is because we don't know 2 to what power equals 14, so that's not 7. But over here, I can use that power property and take the x out in front. So x times log base 2 of 2 equals log base 2 of 14. Again, I know that this amount here is 1 because 2 to the first power equals 2. So this is really just an x times 1 is x equals log base 2 of 14. Normally we just stop here if they wanted an exact answer, but they're actually asking us to round our answers to the nearest hundredth. So we're going to go on our calculator, we're going to type it in just like this, and we're going to hit enter, and we should get approximately 3.8073. It's an irrational number, so it's going to go on forever. But if we round to the nearest 2 decimal places, we should get 3.81. All right, 3.81 will be my approximation. All right, so what that means is that 2 to the about 3.81 power will give me 14. All right, so that's what that means there. For problem number 3, again, first step, we're just really trying to get x isolated. So a good first step would be to just subtract 5 on both sides. And so now we get e to the x power equals 55. And I'm in the same boat I was just in, right? Before we had 2 to the x power equals 14. Now I've got e to the x power equals 55. And hopefully you're saying to yourself, well, I have to take the log of both sides. But what kind of logarithm should I use? Well, if you look at the base is e. And I know I use natural logarithms when I have a base of e. So I'm going to take the natural log of the left and the natural log of the right. We can now use our power property to bring this x out in front. So we know that x times the natural log of e equals the natural log of 55. Again, we know that the natural log of e is just 1 because e to the first power equals e, right? There's really a base of e there, okay? So now I just have x on the left equals the natural log of 55. If they wanted an exact answer, you just leave it like this. But because they're asking us to round, you have to type that in your calculator. And this value is going to be approximately 4.01. So what that means is that e, remember e is about 2.7. So 2.7 to the 4.01 power is going to get me about 55. All right, last one here for problem 4. A little bit more, kind of solving equation aspects here with moving stuff away from the letter t. But what I'm going to do first is I'm just going to add the 4 to both sides. So now we've got 2 times 3 to the 2t minus 5 power equals 15. And then kind of like we did with problem number 2, we had to divide by 3 to get that exponent by itself. So if I divide both sides by 2, 2's cancel on the left. So now 3 to the 2t minus 5 power equals, you can leave it as 15 over 2, or you can leave it as 7.5 if you're more comfortable with the decimal. And now we're really in the same position as we just had here, right? We have a power equals a number. Same thing here. A power equals a number. So what I can do is I can use a logarithm on both sides. Now the question is, do I use the natural log, the common log, a log with some number base? And again, the answer is by looking at what your base is here. So because we have a base of 3, I want to use the log of 3. So log base 3 of 3 to the 2t minus 5 power equals log base 3 of 7.5, right? Whatever log I use on one side, I have to use the same one on the other side. So now I can use my power rule. We can take out that 2t minus 5 in front. So 2t minus 5 times log base 3 of 3 equals log base 3 of 7.5. Okay. Now I know that log base 3 of 3, hopefully you're saying this in your head now, log base 3 of 3 is 1, right? Because 3 to the first power is 3. So all I have on the left side is 2t minus 5 equals log base 3 of 7.5. And all I have to do now is move the 2 and the 5 over to the other side, and we're going to have t all by itself. So to do this, I'm going to have to add 5 on both sides. Now this is where you have to be very careful. At this point, I have 2t equals log base 3 of 7.5 plus 5. If you were to type it in just like this on your calculator is going to assume that it's taking the log base 3 of 12.5, which is wrong. You need to take log base 3 of 7.5. Separately, after that, you are adding 5 to that number, right? Because remember, log base 3 of 7.5 is a number, right? 3 to some power equals 7.5. So this right here is just some decimal. So if you add 5 to the 7.5 and then take the log, it's going to give you something totally different. So you need to remember that before you add this 5, you might want to put parentheses around this logarithm. That way your calculator can calculate that first, then add 5 to it, and then we'll have to divide both sides by 2. So this whole thing will get divided by 2. So on my calculator, I would type in parentheses, log base 3 of 7.5, close parentheses, plus 5 is also in the numerator. All of that is over 2. And then if we hit enter, we should get approximately 3.42. 3.42. All right. And so what that means is that if I plug in a 3.42 in for t, it would come out where the left side equals 11 and the right side also equals 11. Okay. And that would be that. All right. I have one other problem that I want to show you. Now, this is not written down in the notes anywhere. This is just an extra problem that I have for you. So if you want to find some blank space somewhere and then you can write this problem down. I think the very last page of the notes packet has a blank page on the very back. So I'm just going to do it over here. The problem that I want you to write down is 3 to the x power equals 8 to the x plus 1 power. All right, actually, sorry, I changed that. Make it x minus 1, just so we can work with some negatives here. All right, so if I look at this, it's a little interesting because if this 8 was a 3, right, if that was a 3 here, it'd be easy, right? We could say that x equals x plus 1 and we'd be on our way. But because I don't have the same base, I can't say that my exponents are equal. So we have to be a little creative here. And what I know is that if I'm giving something in exponential form, we said that it makes sense that I'm going to have to use logarithms to get it out of that exponential form. So let's go ahead and let's start with that right away. Let's go ahead and let's take the logarithm of both sides. And the question now is, what should my base be? I don't want it to be the natural log because I don't have any e's anywhere. So it's going to be the log of something. Now, in a problem like this, you can actually choose. You can leave it as the common logarithm like this if you want, or you can pick log of 3, or you can pick log of 8. All right, it doesn't matter which base you choose. Typically, I will say that it's best, more often than not, it is best to choose the base that has the more complicated exponent. So because this exponent here is a little bit more complicated than the letter x, it's going to be a little bit easier on me if I choose my base to be 8. Okay, I could choose a 3 if I wanted to. That'd be perfectly fine. I could still get the correct answer, but it's going to be a little bit less work. It's going to be a little bit easier if I choose the base of the exponent that's a little bit more challenging, the one that has a little bit more stuff going on. If they're about the same, like if this was like an x plus 2, it's really not going to make a difference. But if there's a clear winner, like in this case, this one's more difficult, it's a little bit more going on with the 2 terms, I would definitely choose log base 8, okay? So from here, we are going to use our power property. Now I can actually use this on both sides with the x and with the x minus 1. So we're going to bring both of these out in front. So I've got x times log base 8 of 3 equals x minus 1, that's all together still, it's stuck together, times log base 8 of 8. Now, on the left side, nothing is really going to simplify here, but I should see that on this side, we do have some simplification, right? I know that log base 8 of 8 is just 1. So that means that x times log base 8 of 3 equals x minus 1. All right. And now I want to try to get x by itself, but the thing here is that I've got an x on the left and I've got an x on the right. So what's going to be best is if I move all the x's to the same side. All right. Since my constant is on the right side, it would make sense if I move this x to the left side. So what we're going to do is we're going to subtract x on both sides. Those will cancel on the right. And now I have x times log base 8 of 3 minus an x. Remember, this is not all together. These are separate things. This is a whole thing here. The minus x is completely separate. And that's going to equal -1. So now I notice that I've got these two terms, right? I have x times log base 8 of 3, and I've got a minus x. So what I can do with these two terms is I look at these two terms and I notice, right, we've been factoring all year, so I should be able to see that I have a GCF, right, greatest common factor. And if I look at both of these terms, I see that they both have the letter x in common. So I'm going to factor out the GCF of x. That's going to leave me with log base 8 of 3 minus 1. Right? If I distribute, x times log base 8 of 3 is this right here, and x times -1 is this right here. So it does check out, it does work. And that's going to equal my -1. And would you look at that, we just turned two of these x's into a single x here. So x is now all by itself. We just got one of them, which is great. So the last thing I have to do is just divide both sides by log base 8 of 3 minus 1. Divide this by log base 8 of 3 minus 1. Now remember, this 3 minus 1, you can't have this together. You can't just do it, make it a 2. This is something separate. This is its own thing. This is its own thing. All right. You have to make sure on your calculator that you separate it. If you combine those together and make it a 2, you're going to get a wrong answer. You have to do log base 8 of 3 separately and then a -1. Okay. We're going to see these cancel because it's the same value. So now we end up with x equals -1 over log base 8 of 3 minus 1. All right, and this one we can go ahead and we're going to just approximate this. If they asked you for an exact answer, you would just go ahead and leave it like that because that's as simplified as you can get. And I did not do a good job preparing for this, so I didn't do the answer yet on my calculator. But go ahead, type it in your calculator and see what you get for this. Looks like I end up with, let me make sure I just typed this in correctly. I did not type it in correctly. Give me 1 second. Sorry about that. -1 over log base 8 of 3 minus 1. Okay. Think I've got it typed in. Yes, I do. All right. We should get about 2.12. All right. So that should be your answer there. Okay. If you have any questions, I will, hopefully I'll be back tomorrow if I'm feeling better. So I should be there tomorrow morning or after school or during one of your free periods. You can just come and swing by. All right. Thanks for watching. If you have any questions, you can use the Math Center or anybody from the other algebra classes has already done this lesson, so you can ask them for help if you need it.